Hey guys, I just wanted to do a quick tutorial on how to set up a HEC-RAS model using Civil 3D. So right here I've got loaded just a background satellite image. Our project location is right here. We're doing a little bridge. So we'll do a HEC-RAS model, water model to analyze the stream elevations and figure out our freeboard. So first thing I'm going to do is load in a surface. So on my tool space, and that's this button here on the home ribbon, I'm going to create a surface from a DEM. A DEM is a file format that has basically pixels for each location. So square data. And I went to my elevation, and the file is actually there in the folder. It's this TIFF file right here, but I can't see it here because my filter is set to DEM. So I'm going to change that to a geotif. That will allow my image file to be loaded into the project. It's an image, but each pixel is an elevation. So it ends up being surface data. You can see from the contour lines, I've got a bunch of contour lines kind of close here. That represents the banks where the sides are steep. Where these contours are farther apart, you can see that's the stream. The stream bottom is pretty flat. So I've got contours, and then up here would be the bank, the floodplain out on the sides. These contours here, that's just a big hill that is off the screen a little bit. So what I'm going to do, there's a couple ways to do this. I'm going to use an alignment to model the middle of my stream. So right now, upstream is on the right side. That's where the mountains are. Left side, that's where Utah Lake is. And I'm going to start at the bottom and work my way up the center of the stream. So I'm going to use an alignment. I'm going to go to Alignment Creation Tools, and then I'm going to give this a name. I'm going to call it Hobble Creek Centerline. My starting station is going to be 0, and I'm just going to stick with the default styles. Okay, once I have my alignment creation tools, I'm going to choose tangent, tangent with curves. That will make it so that anytime I have two line segments coming together, it's going to give me a curve, which helps me approximate the middle of the stream. Okay, notice that my snaps are on. I'm going to hit F3 to turn my snaps off so that I can draw without my mouse getting sucked to some point. And as I do, I'm just going to start on the left side of my surface here. I'm not going to go over here, otherwise my elevation is 0. So I'm going to start to the right of that. And I'm just going to kind of click my way down the middle of the stream. I can use the middle mouse wheel to pan as I go. And then I can come back and refine this later if I need to. When I get to the end, I'll hit the space key to finish drawing my sample line, or my feature line, my alignment. Wow. Notice we have these little labels. It just shows the stationing along this alignment. So I'm starting at the downstream end, working my way up. And over in my tool space here, you'll notice that under alignments, centerline alignments, I have a centerline alignment that I created, Hobble Creek centerline. Okay, next thing I'm going to do is I'm going to add some sample lines. Well, let me fine tune this just a little bit. So let's say I need to adjust some of the radius. I can come in with these little blue dots, and I can adjust my curvature or whatever I need to a little bit. Maybe I need to pull that down, whatever. I can fine tune that a little bit. So it's in the middle of my stream. All right, now I'm going to add some sample lines. So I come up here to my sample lines button, select an alignment. And then it's asking me for a name. I'm just going to leave sample line collection 1 as just stick with the default naming here. I'm going to stick with the default styles, and I want to make sure that my surface is checkboxed. So right now I have a grid from a DEM, that LiDAR that I brought in. Make sure that checkbox is selected so that the sample line has the elevation data from that surface. All right, so now I can click wherever I want, draw some sample lines. However, I'm going to do, because this is a river and I want it equally spaced, I'm going to go by range of stations. And then this will let me choose where to start it and where to end it. So I'm going to start at the beginning. I'm going to go all the way to the end. I'm not going to stop at a certain left or right distance according to an alignment. I am going to go 50 feet to the left, and I'm going to go 50 feet to the right. So it's going to start at the center. It'll create a sample line going 50 feet to the right and a sample line going 50 feet to the left. And then I'm going to sample every 50 feet along tangents, curves, and spirals. So starting at the beginning, I'll have a sample line every 50 feet, and then I don't need any additional sample control. So I hit OK. That will create these little green sample lines here. I'm going to hit escape because I'm done. And then I can go back and I can adjust these sample lines as necessary. When you're creating HEC-RAS model, it's very important that your sample lines are perpendicular to the flow. So if I'm at low flow and my stream is staying within the bank and the velocity of the water is parallel to my stream center line, then I would want these sample lines perpendicular. If I have high flow and the river's hundreds and hundreds of feet wide, my velocity would be basically the same direction left to right. Well, I guess it's right to left, but so you have to do a little bit of fine tuning there. So I'm just coming in here and I'm looking, making sure that all of my sample lines are perpendicular to the flow. They're perpendicular to the center line already, but I just want to make sure they're perpendicular to the flow. So maybe right here, I'll clean that one up a little bit. Straighten that out. Maybe that one can straighten out a little bit. And you're just trying to, it's a little bit of an art form. You're just trying to make it as perpendicular to the flow as you can. Oh, got pretty crazy there. Okay, once I have all my sample lines, next thing I'm going to do is identify where the river flow switches to the river bank. And the reason this is important is because in your hydraulic equations, you have what's called a Manning's in value that specifies, it's basically the friction of the stream bank and the stream bottom on the water. And the more friction there is, the slower the water is going to go. So the water here in the middle, where it's used to flowing, is going to have fewer obstructions, less friction, and the water on the banks, where there's trees and rocks and things like that, will have more friction. So we're just trying to identify the place where that friction or that Manning's in value changes. So I'm going to come in and basically I'm going to be tracing the bottom of this contour line, change in slope. So I have steep stuff here, flat stuff here, and I'm just going to trace roughly. And the only place it matters is where the sample line crosses the bank. Everything in between the sample lines is data that's lost, so don't bother modeling it. It's a waste of time. I'm going to come back to an alignment. I'm going to create another alignment. This time I'm going to call it Hobble Creek Right. Hit OK. Tangent, tangent with curves. And I'm just going to click my way downstream. I'm trying to match where the stream bank goes. This can be fine-tuned later in the cross-section editor in HEC-RAS. Space to finish. I lost my mouse. There it goes. All right, I'm going to close that alignment editor, and I'm going to do it again. Alignment creation tools. This time I'm going to go Hobble Creek left. And tangent with curves. I'm going to do the same thing, tracking this left bank across. And obviously I'm going pretty fast here. Place to finish, close that. Okay, so now just to recap, I have a centerline alignment, I have a right bank alignment and a left bank alignment. Downstream is on the left, upstream is on the right. So all of these are going downstream to upstream. There's a little bit of a bug between AutoCAD and HEC-RAS where the directions get flip-flopped, but I found that it's easier to go downstream to upstream in CAD and then reverse it in HEC-RAS later, just because they use different opposite conventions. Okay, so I now have all the geometry that I need to export to HEC-RAS. So let's go ahead and do that step. It's under the Output tab ribbon. We're going to export to HEC-RAS right here in the middle. And it asks us what surface we want to use. I only have one, so that's going to default. I don't have any sites created, so I'm going to do none. After I do this process, it will create a site, and I'll have to select that the next go around. But for my reach alignment, I'm going to choose Hobble Creek centerline. For my sample line group, I only have one. It was that SL collection 1. My river name, this is just for later when it goes into HEC-RAS. Give it a name, and then I'm going to use this check to use riverbanks. The left bank, that's this top one. And then the right bank is this bottom one. Hit export. And I'm going to call it hobblecreek.geo. And I hit OK to finish. And now in my folder, I have this .geo file. I can open it with Notepad. I can look at it's just a text output. So it gives like my stream center line, and it has elevations and locations. Then it has a whole bunch of cross sections, all the elevations, distances for all those points. This text file can then be imported into HEC-RAS. And I don't know if I actually have I do have HEC-RAS. Okay, let's go ahead and show how that works. So this is HEC-RAS, super old school. I'm going to import my geo file here. So I'm going to open my geometric data. I'm going to import geometry data in a GIS format. And then I have to locate my file, which is super old school. So let me see if I can, I don't even know what drive it's on. C, users, drive, drive, on a Google Drive. Okay, here's what I'm going to do. I'm going to copy it to the root of my C drive real quick. Because this is hard to find. Okay, so I just pasted it into my C drive so I can open it here. I'm going to hit OK. That brings this import data. I'm using US units. I don't have to change anything. I just hit finish. And I now have my streamline. stream centerline that's blue. I have all of my cross sections that are green. These little red dots represent the location where it transitions. And then I can open up my cross section editor and you can see my stream cross section. You can see these little red dots indicate where it transitions from bank to middle, and you could put in your Manning's end values for the left over bank channel, right over bank, and then you can go up and down through all your cross sections and actually run your HEC-RAS model from there. So there you go. There's a quick tutorial on how to import or how to create the geometry data to use in a HEC-RAS model.